Okay, so let's get started. We know that AI is changing everything to these days. AI is changing the way we interact with our mobile devices. Some of our favorite websites, like Facebook and so on, heavily using machine learning and AI to improve these services, and it's even changing the way we travel, right? So it is important that we ask what are the security implications of this. Now, if you ask some people in the science and technology community, they might give you answers like this, saying that it will end up in the end of the human race, or some other people might say this is not something we need to worry about in the long term. But our perspective is that there is some dangerous risk in the short term. If you think about the way we consume information online today, AI can be used to manipulate the information or content that we consume online, right? And this can lead to destruction of the trust that we place in businesses or entities or even humans that we interact online. So, in this talk, I will demonstrate one such risk by identifying an AI based attack on online review systems. So, I'm pretty sure most of you are familiar with some of these sites. We use these sites to figure out the quality of an online business, quality or the products that we want to buy online. Unfortunately, these businesses are plagued by fake reviews. So, if you've shopped on these sites, you must have experienced these fake reviews or even heard about them. And usually they are created with the intention to mislead users. And businesses may use these fake reviews to boost their own reputation or even hurt competing businesses. Right? So let's take a look at how these fake reviews are generated today. So one of the most primary way of how attackers do this today is using these malicious crowdsourcing sites, also called as crowdturfing sites. And these sites provide human workforce for these malicious tasks. Let me give you an example of how this works. Say there's a customer who wants to buy some fake reviews for their business. They will go to these crowdturfing site. They can pay them and hire human labor, who in turn can be even trained to write high quality fake reviews. But what keeps these sort of attacks in check today? There are two main reasons. One is that these reviews are not cheap because there's a human involved in writing these reviews. This is a screenshot of one site that claims to give you fake reviews, high quality fake reviews for sites like Yelp. As you can see, the numbers, if they're small, it's around $85. But this is just one data point. So we ourselves did an estimate and we found out on Yelp, or say a single fake review can cost you around $20. Now, the second sort of weakness of these attacks is that most of the time these workers on these sites are eager to perform and they end up posting reviews in a very synchronized fashion. Now, prior work has used these sort of time based features which can detect the synchronized patterns among these workers. And they've been able to successfully catch these crowd turfing workers. But what if you could do away with all these weaknesses and using AI to strengthen these kind of attacks, right? So let me give you illustrate how this might happen. You have again a customer who wants to buy fake reviews. So instead of going to a crowd turfing site, you go to this platform that hosts an AI program that has been trained to write fake reviews. And then you can generate your fake reviews and post it to these sites. So clearly, if you think about this attack has some strengths over the previous approach. It is scalable because you don't have to hire a human to write a review every single time. The AI program can generate unlimited number of fake reviews for you. So this immediately reduces the cost for the attacker. And more importantly, if you think about this, now you have complete software control over your attack. So whatever defense scheme that people have come up with for using, looking at synchronization techniques and so on, you can try to evade them. So this makes the attack very strong. But this still has there's an important question that's still unanswered, which is, can AI generate meaningful text today? And our hypothesis is that a special class of neural networks called as recurrent neural networks can do this in certain restricted contexts. So what I mean by that is RNNs can generate short, meaningful pieces of text on certain narrow, specific topics. And interestingly, this works very well for attacking online review systems because reviews are typically short and talk about very specific topics about, say, a restaurant or a particular type of business. Now, let me give you a few samples of reviews that we generated using an RNN. This is a very positive review for a restaurant on Yelp. As you can see, this talks about the quality of the food, the quality of the service, and even says that I'll be back to visit the restaurant again. Right now, it can also be trained to generate a negative review. And here is another example. And in fact, the RNN even learned to put the text in uppercase, basically indicating that it did not like the place. So let's take a look at how we can do this, right? Let me give you the details. Now, before I go into talking about RNNs, let's take a quick look at how traditional neural networks work. It's a very simplified picture of how traditional neural networks work. Traditionally, you use it for classification tasks like telling apart from a cat or a dog. So you have a multi-layer network. You have an input layer where you feed these images, and you have an output layer that gives you the classification result. And these hidden layers in the middle are called hidden layers, and they have neurons that can be activated for this task. An RNN, it's a little bit different. So in an RNN, you learn from a sequence of characters to predict the next character because you want to generate text. So at a high level, similar to a traditional neural network, you have an input layer, a hidden layer, and an output layer. So at the input layer, you feed in a character in the text sequence one at a time. And in the output layer, it predicts the next character in the sequence depending on what it has seen so far. Now, the main difference is that the hidden layer has a loop in it, which basically helps it to predict the next character based on what it has seen so far, right? Because in a text, we very well know that a single prediction would depend on what are the predictions before, unlike in the traditional classification task. So once you sort of have this model, you can use it to generate text. You make one prediction, you feed it back in, and it will predict the next character, and so on. Right. So let's take a look at how you would train such an RNN model. Uh, Now, in this case, we want to use it for an attack to generate fake reviews, right? So you want to pick a data set for training that matches the domain of your target entity. Right? Say you want to write fake reviews for a restaurant, you want to get a data set of restaurant reviews. So luckily, there are many publicly available data sets out there. So we use a publicly available Yelp challenge data set to train our RNN. Next thing is you want to choose a good model and for your RNN. So we use a well-known model called LSTM, or long short-term memory model, which has been shown to perform very well in practice. We use two layers, and the hidden layer has 1024 hidden units. Now let's see how we can, once we train the model, how we can generate these reviews. Now, simply sampling reviews from the RNN is not enough because our goal is to make these reviews as realistic as possible to fool real users, right? So we want to do two things. First, what we do is we try to tune the linguistic characteristics of the generated text. So what I mean by that is we want to avoid meaningless words or complete crazy misspellings or even repetitive patterns in the text. Second, we want to customize the review for the target entity. Because in an RNN, you don't really have control over the text that you sample. You cannot ask it to get a review for an Italian restaurant, for example, right? So you don't necessarily want to generate a review for an Italian restaurant that actually talks about Japanese food, right? It would be obvious. So let's take a look at how we would tune the linguistic characteristics, the first part. So in an RNN model, we can use a parameter called the temperature to control quote unquote novelty of the text. So I'll talk about this in more detail. So temperature ranges from any value greater than 0, and very low values of temperature would give you less diverse text, and a high value would give you more diverse text. So in more detail, when you have a low temperature, you're essentially sampling from this probability distribution of the characters, right? You end up picking more likely characters for your prediction. So you have more conservative predictions. So your text might actually look like this, where you may have some repetitive patterns. So if you go to a very high temperature, then it's the other extreme where you end up sampling characters that are less likely. It will give you more diverse, novel sequences of characters, but you have to be careful about misspellings or having completely meaningless text. So we eventually figured out a good range for sampling text is in the range 0 to 1. And I will present you more results showing how this actually ends up working. So the next part is how you customize your review, right? This is, as I said before, is because you cannot control the context of a review when you sample it from the RNN, right? So here is an uncustomized review. It actually talks about Japanese food. We want to target it for an Italian restaurant. So how would we do it? So the first thing we want to do is we want to choose a context that we want to customize it for. So I will, in this case, I will choose the context of food or food names, right? And we identify words in this review that relate to the food concept. We use a lexical database for that, right? Then the idea is to replace these words by better fitting words that match the target, right? And to do that, we build a set of reference data sets for different types of cuisine, right? So if you want to target an Italian restaurant, we can pick food names matching Italian cuisine, and you simply replace these words, and there you have a review that is customized for an Italian restaurant. Right. Now, if you have these review generated, I think the important question is basically understanding what are the quality of these reviews or how effective is this attack, right? Now, we have a lot of evaluation in the paper. I will go over these three main questions in this talk. The first question is there is a lot of work on detecting fake reviews online using machine learning classifiers. So, can we use these techniques to detect machine generated reviews or reviews generated by the RNN? Right? The second question we want to look at is can humans tell apart between these machine reviews and real reviews? And the last question is important because our ultimate goal is to fool these users and potentially impact their judgment about a particular place, right? So we also want to see how useful they find these machine generated reviews. So let's take a look at the first part of using ML based classifiers to detect machine reviews. So what we did was we tried to build the best performing classifier based on prior work. There's a lot of techniques using structural, syntactic, and semantic linguistic features. We used the best performing ones, and we built a classifier that's trained on real Yelp reviews and fake reviews identified by Yelp. And we applied this classifier to real Yelp reviews and machine reviews that we generated. Let's take a look at the performance. So in this graph, you have detection performance as a function of precision and recall as for detecting reviews generated at different temperatures. And one thing you will observe is that as the temperatures increase towards 1, it becomes harder and harder to detect these reviews. And in fact, the detection performance is very poor. You get a precision of only 18% in this case. So what this means is, if you're not familiar with precision and recall, is that you not only you're not able to catch a lot of these machine reviews, but you also wrongly end up flagging a lot of real reviews as machine reviews or fake reviews, which is bad, right? So these existing approaches are not very effective at catching these machine reviews using linguistic features. So the next question that we had was figuring out if a human can distinguish between machine reviews and real reviews. So we did a survey on Amazon Mechanical Turk. We had over around 600 surveys, and each survey contained 20 reviews where a small random fraction of those reviews were machine generated reviews. And we asked users to mark reviews that they believe to be fake. So again, we look at the performance of detection, and we use precision and recall for that. And you see the same trend where the detection performance actually decreases with the temperature, right? So if you're trying to catch reviews at a higher temperature, it's much harder for the human to distinguish them. And the precision and recall values are still lower, even though the precision values is a little better than the machine-based detection that I showed earlier. Okay. So finally, we have this question whether humans find these reviews quote unquote useful, right? So what we did was we also asked these users when they flagged a review as real, whether they how useful they found this review to be, right? So Yelp also has a similar metric when when you read a review, you can rate it as being very useful on a certain scale. So we use a scale from 1 to 5, and let's see how the results turned out. So we compute the average usefulness score for machine reviews and real reviews. Now, definitely, interestingly, machine reviews are very close in usefulness score with real reviews. Now, this is dangerous, even though it's a little lower than that. So, what this means is that humans not only find it hard to detect these machine reviews, they also find them to be quite useful in understanding about the place, right? So, that is bad. Okay, so far, mainly I've talked about the attack part. We do want to have some sort of a defense, right? Well, let's take a look at why building a defense is challenging. Based on the results I've showed so far, we clearly know that if you look at the high level linguistic features, you cannot tell apart from machine reviews and real reviews. But there's an even more fundamental problem. This is actually a machine versus a machine scenario, because now, whatever defense classification technique that we bring up, the attacker can try to tweak their ML model to generate reviews that would bypass that defense, right? So that's very challenging. So our key insight is to basically leverage a fundamental limitation of machine-based text generation. So you have sort of this pipeline where you have a training data set, you have a model, and then you're generating these reviews. Now, the interesting thing is this model is a finite size limited model, and it is only so much that it can learn from these training data set, right? So there is some information loss in the training process. So even though the generated text looks very similar based on high level linguistic features, they actually distort the low level character level distribution. In other words, the human written text and the machine text, they diverge in terms of the lower level character level distribution. So if we can design a scheme that looks at this distribution, we can try to defend against this attack. So let's take a look at the methodology for the attack. Similar to prior work, we use a supervised scheme where we assume that we have some amount of machine reviews as well as real reviews. But we show that we can do this defense with very limited amount of ground truth. So, say you have some training data set of machine reviews and real reviews. First thing what you do is you build a language model for each of these training data sets. You build two separate language models, which basically characterizes the character distribution in each of these sets of reviews. And we use an RNN for building the language model. Next, given an unknown review, you can basically try to figure out which language model would this unknown review fit better, right? So if it fits better in the language model of the fake reviews, you can mark it as fake. And if it fits better in the other one, you can mark it as real. So that's at a very high level, right? Now let's see how this would perform in practice. So we used this approach to detect machine reviews that we generated. We used the temperature 1 reviews because they performed very well. And we use both real reviews and machine reviews to train this technique. And we also definitely compare with prior work, the linguistic classifier that I used earlier. So let's take a look at how the defense performance varies as we give different amounts of ground truth for the training process, right? So here for detection performance, I use F-score, which is a function of precision and recall combined into a single metric. So higher value is definitely better. So as you can see here, the linguistic ML classifier performs very poorly, especially it gives very low performance when you have very limited amount of ground truth. Now let's take a look at our performance. Now, as you can see, even with very limited ground truth information, we're able to outperform the ML classifier. So what this means is that the signal that you want to detect these machine reviews are at the low level character distribution and not based on higher level linguistic features, which is easy to mimic in terms of the real reviews. So now you have a defense, but the attacker can still try to evade detection in different ways, right? One way is the attacker tries to reduce that divergence in the character level distribution. And the way they can do that is by building a higher quality model or a larger model, right? Because I said earlier that the limitation of the attack is because you have a finite size model, right? But when you have a larger model, it also increases the cost for the attack because you might need more computational resources to train the attack model, you need more data, or it might even take a lot of training time. So in this case, let's take a look at how the training time would vary for the attack, right? So here in this graph, I show how detection defense performance as well as the training time for the attacker would vary as the attacker changes the size of the model, right? So larger size means higher quality model, right? So as you can see, if you look at the black line, you'll see that our defense performance does decrease as the attacker uses a higher quality model, right? As expected. But at a certain point, like beyond 1024 size model, you will see that the training time really shoots up. So the attacker, for a small gain or a small reduction in defense performance, the attacker has to incur a higher, much significant overhead, over 400% in training time. So that is the cost of the attack that the attacker has to incur. Okay. Sorry. Yeah. So basically, the detection performance decreases when you reduce the divergence between machine reviews and real reviews. I'll talk after during the QA session. No, this is the detection defense performance. So in this talk, I've basically talked about attacking restaurant reviews on the platform site like Yelp. But clearly, this sort of an attack can potentially work on other similar sites like, TripAdvisor, where you have hotel reviews, or Amazon, where you have product reviews, because the context and the size of the reviews is very similar, right? Now, we are trying to look at future work where we explore other kinds of attack. For example, how you can manipulate social media discussions, because there you have conversational text, as well as attacks where you try to strengthen existing Sybil attacks. Because another problem is people creating fake accounts, and whether these sort of content generation techniques can make these fake accounts look very real for the existing defenses. So in the paper, we have a lot more detailed evaluation of other evasion strategies and more details about our attack. And I'll be happy to take more questions if you have.
Okay, I'll start with the question. So how do you make sure that the generated sentences are grammatically correct? For instance, the tense, voice, the subject, verb agreement.
So we don't necessarily do anything particular to ensure that. So all we need to make sure is that the RNN model reaches a point where the loss curve, if you look at its loss curve as well as its perplexity, it's decreasing, and you're not getting any more gains from training it further. So in other words, you don't. As long as you train a good model, it ends up matching the verbs, the syntactic features that you mentioned pretty well with the training data set.
Did you evaluate the percentage of the generated sentences that are grammatically correct?
We did not do that analysis, but we did look at individually how do these syntactic or semantic features compare with real reviews. So I can show you one example. So this is a fraction of verbs, and one is the machine review and the other are real reviews.
Okay.
As you can see, at higher temperatures, basically these lines end up coinciding. So what this means is that it is matching the syntactic features of real data sets.
Well, this is not a good measurement because the percentage of verbs doesn't really mean it's correct. Your
Right.
verbs could be in the wrong place,
Right.
or maybe the verb doesn't agree with the subject or the object.
Right. So
another quick question is that
So just to answer that part, we did look at a lot of different features. So we also looked at semantic features.
Yeah.
They also have the same trend. And ultimately, we had the user study where users found
Okay.
these reviews to be real.
Okay.
Right.
Also, quick question is about the performance. Why is that a sudden jump from 1024 to 2048
So
on the robustness?
yes.
So is it because there's a memory limit that's beyond 1024? Your computer swaps like crazy.
Yes. So the function of the training time is a function of many things, not just
Not this one.
yeah, and I understood. I understood.
Yeah, this one.
Yeah. So it's not just a function of the size of the model. There are other hyperparameters that also affect the training time. So when you increase the attack, the model size, You also want to change the other parameters so that you learn a good quality model, and that ends up increasing it a lot at this point.
Okay.
Yeah.
Really great work. Very interesting. I
Thank you.
really liked it. One thing I just wanted to ask or kind of suggest is, did you consider using generative adversarial networks for doing the defense versus attack, trying to basically train
Yeah,
those
got
against
it.
each other?
Yeah, this is a question we get a lot. So definitely, we can use any type of generative models for this problem. So we use one of the simplest models out there, which is a very basic LSTM RNN. So yes, I mean this would be interesting future work to see if GANs can produce even better text. Then that would be interesting to look at.
Yeah, absolutely. Thank you so
Thank
much.
Hi, Sarah Elder in CSU. Question about, you said that the helpfulness was similar for both the machine generated and the actual generated ones. You may not have data, but do you have any notion of why that might be? Were they the right length? Were there certain attributes or certain characteristics of them that made them more helpful?
So what the neural network does is it tries to match pretty much all the linguistic characteristics of the real reviews. So if the real reviews, they have a whole range of length distribution, right? There are short reviews, there are long reviews, there are medium-sized reviews. They will end up emulating them, right? So essentially, that is the effect that you're seeing here. So it looks pretty much hard to say whether this is fake because it's too short or too long. So it pretty much does a good job with that. We don't have to try extra hard to do that. The neural network does it automatically.
Hello, this is Shirin from UC Santa Barbara. So when you gave some reviews to users to say if it's fake or not, did you also give real fake reviews to them to evaluate?
We did not. So in this case, we gave them machine reviews.
Only machine reviews?
Yes.
Because I have the suspicion that in general, it's very hard to say a review
Oh
is
yes,
fake
it is. It
or
is.
not.
Yes,
So
it
I
is.
think, I
Yes.
don't know if like showing that number is
So the important point to note is that when you use human workforce to generate these reviews, they already do a good job with writing, and now you have a neural network that can do this automatically for you and still achieve the same or maybe perhaps better quality in this context, right? So that is still a dangerous thing. That's the important thing I would keep in mind.
Hi, Lorenzo De Carli, CSU. I thought your point about matching reviews to the particular type of business was interesting because it's sort of implying that you really generate templates that you can reuse for different purposes. I was wondering if reusing those sort of templates would give any advantage to the adversary or would make detection trivial.
You're talking about the customization part,
Yeah,
right?
by which I mean generating one of those reviews and then reusing it multiple times by just changing a few details.
Yeah, so you have full flexibility once you generate these reviews. You can think of any sort of natural language, linguistic NLP methods that can further improve the customization process. So you feel free to free to do all those techniques, right? We can use those techniques to further improve the customization process, if that's what you're asking. And you don't necessarily want to use the same review again and again. It would be an obvious attack, and there's no reason to do that because the RNN can give you an unlimited number of reviews.